A rational expression is an expression that is the ratio of two polynomials. I have the definition written here, and I gave you an example. If you look at two polynomials, the ratio, a fraction between the two, so notice I have a polynomial in the numerator and in the denominator. So let's look at, what we're going to look at first in this part is we're going to look at how do you evaluate a rational expression. The same way you evaluated anything else in algebra so far. What we do is plug and chug. We're going to give you a value for the variable, plug it in, simplify it. So I see that I want to know, evaluate this expression when x equals -1. So I'm actually going to replace x with a -1 and simplify it. Make sure that you square that negative because x is being squared. Really important to have the parentheses around that in that case. So I'll end up with 1 minus 4 over -4. And I should get -3 over -4, which ends up being 3/4. Would be the simplified form. So I just made a few of these here, some different points here. Let's try when x is, different values for x. Let's try when x is equal to 2. So let's evaluate this thing. If I plug in 2 for x here, I'm going to end up with 2 squared minus 4 all over 2 minus 3. I'll end up with 4 minus 4 all over -1, which is 0, over -1, which 0 on top is always 0, right? 0 on bottom is undefined. So that's one thing to note. How would that expression become 0? You'll see some questions like that. What values would make this thing 0? Well, I know one of them is 2. If I plug a 2 in there, 2 squared, I just look at the numerator to make it 0. 2 squared minus 4, which is 4 minus 4 is 0. Another value will be -2, right? And that's the next one we'll try because when you square the negative, it becomes a positive. So if I wanted to know, I want to evaluate this thing when x equals -2. I end up getting 4 minus 4 all over -5, which ends up being 0 over -5, which is 0. And that's my answer for that one. So those are the two values actually for that expression that make it 0 when you evaluate it, 2 and -2. And so that's just an important point. If I ever wanted to know what makes this 0, just look at the numerator, ignore the denominator, and set that equal to 0 and solve. Now, when x equals 3, let's try that one once. I'm noticing by glancing at it here, if I had 3 squared minus 4 all over 3 minus 3, it's going to make my denominator 0. When that happens, I end up getting 0 on the bottom, and we know that that is undefined. You can't divide something by nothing. So you'll get undefined. 0 on top, you get 0. 0 on the bottom, we're going to get undefined. So that's the first kind of thing that we're going to look at. So you'll have a lot of homework problems dealing with that stuff. Now, the last thing I want to mention in this short video is looking at rational functions. So let's define a rational function. A rational function is basically a function that is a rational expression. So let's just use that same example we were looking at. We were looking at this rational expression, x squared minus 4 over x minus 3. Well, one thing that we've learned in the past in other subjects, or I mean other topics in this in algebra courses, telling the reader that that's actually a function of x. So we're telling the reader it's a function. So I could do different things instead of just asking you to evaluate this expression when x equals 3 or whatever. I could actually ask you what is f of 3. And so that's saying, hey, if you plug in 3 for x, what do you end up getting for an output for y? And so if I did ask you for that, I would plug in 3 just like we did last time. We got 3 minus 3. I ended up getting 9 minus 4 over 0, which was 5 over 0, which would actually be undefined. So that would actually be the same problem as looking at just the expression, but not in function notation, and asking you to evaluate this expression when x equals 3. But this is function notation way of saying an input value, the output value was undefined in this case. So anyways, we are actually going to look at some important things. And the last definition is the domain of a rational function. And so the domain of a rational function are all values, are all real numbers, except the value or values that make the function undefined. So basically we're saying, hey, when the denominator is 0. And so looking at this case, I know that I would just take, if I want to find the domain of this, I'm just going to take the denominator and say it can equal 0. If this denominator equals 0, it's not part of my domain. That value is not part of value is not part of the domain. The domain is everything else. So solve for x. Basically, x cannot equal 3. It can be anything but 3. I accept that as an answer. I'll assume that you mean all real numbers except. Another nice way to say it would be all real numbers except x equals 3. So this is an acceptable answer right here. Just x can equal 3. I would accept this. And then a good way to practice is a shorthand way that we use oftentimes, and you've probably seen in the Math 104 course or the earlier algebra course, is interval notation. So how do I write that in interval notation? It would basically be negative infinity, but instead of going all the way to infinity, say comma, all the way to 3, a parenthesis, not including the 3, then union that with all the way from 3 to infinity. So essentially, if we go from negative infinity to infinity, but I'm taking